Hi, I'm Rishabh. Now, today's topic is associative memory, a subtopic of microprocessors. Basically, it is a subtopic of microorganization. So, there comes 5 topics under it. First is the memory hierarchy, the main memory, associative memory, cache memory, and the virtual memory. What is memory hierarchy? It is a memory unit which is essential component of a digital computer since it is needed for strong programs and data. Memory unit that communicates directly with CPU is called a main memory, and devices that provide backup storage is called auxiliary memory, and all the other information that is stored in auxiliary memory and transferred to the main memory are when needed. So this is a table which shows the key characteristics of memory, computer's main memory system, the location, which is the external and the internal, the capacity, which is in the number of words or number of bytes, unit of transfer, which is in the word or block, access memory, performance, physical type, physical characteristics, and organization. Next comes the main memory. It is a memory used to store programs and data during the computer operation. It consists of RAM and ROM chips, and this is the 2 types of RAM, which is the SRAM and DRAM. SRAM uses capacitors for strong information, and whereas DRAM uses the flip-flop. SRAM is slower and an analog device, whereas DRAM is faster and digital device. SRAM is used in main memory, whereas DRAM is used in cache. Now comes the associative memory, which is our main topic, but I'll be telling about the brief about it, and later will be explained in the video. Now, what is associative memory? To search a particular data in a memory, data is read from a certain address and compared. If the match is not found, content of the next address is accessed and compared. So the searching time can be reduced if a data is searched on the basis of the content. This is what associative memory is. And now cache memory. Cache memory can be explained like analysis of a large number of programs shows that references to memory at any given interval of time tends to be confined to a few localized area in the memory. This is known as the locality of reference. And if an active portion of a program and data are placed in a fast memory, then the average execution time of the program can be reduced. Such fast memory is called as cache memory. This is the figure or the example of a cache memory: the main memory block, the cache block, and the CPU. Now comes the virtual memory. Virtual memory is a concept used in a computer that permit the user to construct a program as through a large memory space is available equally to auxiliary memory. Now address space and memory space. An address used by a programmer is called a virtual address, and set of such address is called a address space.
Hi, this is Ritvik Raj Singh, and this is the detailed explanation of associative memory. So this is the introduction. To search particular data in memory, data is read from certain address and compared. If the match is not found, content of the next address is accessed and compared. This goes on until required data is found. The number of access depend on the location of data and efficiency of searching algorithm. This searching time can be reduced if data is searched on the basis of content. A memory unit accessed by content is called associative memory or content addressable memory (CAM), or associative storage or associative array. This type of memory is accessed simultaneously and in parallel on the basis of data content. Memory is capable of finding empty unused location to store the word. This is the flowchart of associative memory organization. Up here is argument register, and then comes the key register. Associative memory is organized in such a way. Argument register A. It contains the word to be searched. It has n bits, 1 for each bit of the word. Key register. This specifies which part of the argument word needs to be compared with words in memory. If all bits in register are 1, the entire word should be compared. Otherwise, only the bits having k bit set to 1 will be compared. Associative memory organization. Associative memory array. It contains the words which are to be compared with the argument word. Match register M. It has m bits, 1 bit corresponding to each word in the memory array. After matching process, the bits corresponding to matching words in match register are set to 1. And this is the diagram for associative memory organization circuit. And key register provide the mask for choosing the particular field in A register. The entire content of A register is compared if key register content all 1. Otherwise, only bit that have one in key register are compared. If the compared data is matched, corresponding bits in the match register are set. Reading is accomplished by a sequential access in memory for those words whose bit are set. Let us include key register if kj is equal to 0. Then there is no need to compare aj and fij. Only when kj is equal to 1, comparison is needed. This achievement by O-ring each term with kj. Mi equal to x1 plus k1 dash into x2 plus k2 dash into x3 plus k3 dash ... and so on. And this is the final circuit we have.
Hi, I'm Vidhi, and here we continue with the associative memory organization. The figure here shows the match logic for one word of associative memory. The associative memory organization, we're going to study about two operations, write and read. The write operation: if the entire memory is loaded with new information at once prior to search operation, then writing can be done by addressing each location in sequence. Tag register contain as many bits as there are words in the memory. It contains 1 for active word and 0 for inactive word. If the word is to be inserted, tag register is scanned until 0 is found and word is written at that position and bit is changed to 1. The read operation: when a word is to be read from an associative memory, the contents of the word or a part of the word is specified. If more than one word match the content, all the matched words will have 1 in the corresponding bit position in match register. Matched words are then read in sequence by applying a read signal to each word line. In most applications, the associative memory stores a table with no two identical items under a given key. It is a hardware search engine, a special type of computer memory used in certain very high searching applications. Composed of conventional semiconductor memory, usually SRAM, with added comparison circuitry that enable a search operation to complete in a single clock cycle. SRAM is a type of semiconductor memory that uses stable latching circuitry to store a bit. Types of associative memory: there are two types of associative memory which both are used in different conditions. The first is auto-associative. Auto-associative memory takes back, retrieves a previously stored pattern that most closely resembles the current pattern. Heteroassociative memory. Heteroassociative memory, the retrieved pattern is in general different from the input pattern, not only in content but possibly also in type and format. Neutral networks are used to implement these associative memory models called NAM, Neutral Associative Memory. Advantages of associative memory: this is suitable for parallel searches. It is also used where search time needs to be short. Associative memory is often used to speed up databases in neutral networks and in the page tables used by the virtual memory of modern computers. CAM design's challenge is to reduce power consumption associated with the large amount of parallel active circuitry without sacrificing speed or memory density. Disadvantages of associative memory: an associative memory is more expensive than a random access memory because each cell must have an extra storage capability as well as logic circuits for matching its content with an external argument. Usually, associative memories are not used in applications where the search time is very critical and must be very short.
Hello everybody, welcome to the video. Now we are going to talk about associative mapping. Mapping is basically how the RAM works during a program. Okay, so associative mapping, it is the fastest and most flexible cache organization. It is a fact that fastest and most flexible cache organization uses associative memory. It stores both address and content of a memory word. Okay, at this point you should please take a note that there are certain terminologies that are going to be used, such as word, tag and line. Uh, so an associative mapping, the cached memory stores both address and content of memory word. Then address is placed in an argument register and memory is searched for matching address. If the address is found, the corresponding data is read. If data is not found, it is read from the main memory and transferred to the cache for faster access. This is a fully associative cache organization. You see the main memory over there, which has word 0, 1, 2 up until an n, a general expression. Then comes the cache data. Cache which has a number of data blocks and then specific tag lines, which differentiates one data block from another data block. Then is the memory address, which has a tag and a word which is retrieved from cache as well as main memory. If the it is retrieved from cache if it is present in a cache, if it is retrieved from main memory, it is not present in cache. Then come comparison. Let's compare between two types of cache: the direct cache example and the associative cache example. A direct cache example has a 8-bit tag, 14-bit line and 2-bit word, whereas associative cache has 22-bit tag, 2-bit word, and 2-bit word. Okay, then comes set associative mapping. Cache is divided into a number of sets, as you have probably seen, and each tag differentiates between the number of sets. Each set contains a specific already predefined number of lines. A given block maps to any line in this given set. Example, block B can be any line in set I. That is for this. Let's go back to the diagram. Like any block line in the main memory can point to any data in cache. Then another example, 2 lines per set, 2 ways of associative memory mapping. A given block can be in one of the 2 lines in only one set. Mark my words, in only one set. Then let's talk about two-way set associative cache organization. Again the same slightly modified version of the previous diagram. We have a main memory, we have a cache, and we have a memory address, and then the working. The data is fetched from main memory into the cache and then to the memory address, which now has a tag, set and word, 3 different arguments. Let's compare between now this 3 examples: the direct cache, the associate cache, and a set associate cache. A direct cache has a 8-bit tag, 14-bit line and 2-bit word. Associate cache has a 22-bit tag, 2-bit word, whereas the set associate cache has 9-bit tag, 13-bit set and 2-bit word. Thank you for watching this video.